Hi, my name is Farhana and welcome to the session on trigonometry rules. Have you ever wondered how is it that pilots know in which direction to fly it when there is a strong wind blowing? So, that's going to be one of the questions we're going to answer at the end of this session. We're going to look at how flight engineers will use trigonometry to draw a triangle and use trigonometry and some of the rules we do today to solve that triangle and find the angle at which the plane needs to fly in order to reach its destination. Okay. So far, all the trigonometry you've done thus far has been dealing with right angle triangles. So in grade 10, you've covered all of these sections. However, today, we're going to begin solving non-right angle triangles. And specifically, we're going to be looking at three rules: the sine rule, the cosine rule, and the area rule. A little bit later, we'll be doing some proofs and applications for all three rules. The first two rules will help us to find the lengths of sides as well as unknown angles in non-right angle triangles. The area rule will be used to find the area in triangles when we don't have enough information to use our regular half base times height formula. Okay, so now we'll begin with today's lesson where we will be dealing with the sine rule. And remember, the sine rule is one of those rules that's going to help us to find the lengths of sides as well as the size of the angles in non-right angle triangles. Before we start, we need to get through some keywords. The first word we're going to deal with is oblique. An oblique triangle is a triangle that has no right angled, that doesn't have any right angles in it. So, this triangle ABC, you can clearly see that none of these angles are right angled. So, the sine rule again, we're going to be using it to find some angle that's unknown or the length of some side. So either we'll be finding an angle here, angle A, or we could be finding, for example, the length of AC. Before we begin, we need to revise some of the conventions of labeling a triangle. So let's go back to the board. If you recall, when we label triangles, each vertice, for example, in this triangle, which we call triangle ABC, each vertice is labeled with a capital letter. And so this vertex is A, B, and C. And that also represents the angle. And the side directly across it, so the side directly across A, is labeled with a lowercase of the same letter. So across angle A, we have lowercase a, which means it's representing this side, BC. Okay, and when we have uppercase B, the side directly across it will be labeled with a lowercase letter b. And similarly for C and little c. So what is the sine rule? So the sine rule, let me just clean this up first. So what is the sine rule? The sine rule is a very simple rule to remember. It says sine A over A is equal to, sorry, let me just get this pen. Sine A over A is equal to sine B over B, which is equal to sine C over C. And we have another version of this, the reciprocal version. The reciprocal version, we basically flip that equation upside down and we begin with the lowercase letters on top. So lowercase a over sine A equals to B over sine B equals to C over sine C. So when we're trying to memorize the sine rule, it's really, really simple. We're always talking about sine A over A equals to sine B over B equals to sine C over C. But what happens if our triangle is not labeled with ABC? What then? Let's look at that. So if we have a triangle PQR, as we do here, the side opposite P is labeled little p, and we have labeled Q, little q across from the vertex Q, and similarly with R. So we just adjust the formula for the sine rule using P, Q, and R. So our formula will look like this. Sine P over P equals to sine Q over Q, which equals to sine R over R. And the reciprocal version, little p over sine P, and similarly Q over sine Q, and R over sine R. Okay, so when we're using the sine rule, we need to think about two very important things that we need. In order to use the sine rule, we need to be given one full pair of sides and one half pair. What does that mean? Let's look at our diagram again. If we were looking for side A, we would have to be given the angle across it, and this would be our half pair. And we would be needing to be given another full pair. And what do we mean by a full pair? We need to be given angle B as well as the side across it. So we've got a half pair here, and the red piece is our full pair, which means which version of the sine rule will be used? Again, because we've got sine A, we're looking for the side here. So because we're looking for the side little a, it means we're going to use the version where the sides are in the numerator. It just makes our calculations a bit easier. So we're looking for little a, which means that's the one we're going to start off with. So we're going to use a over sine A, that piece. And because the other pair we're given is this full pair we've given, which comes from this part of the equation, b over sine B. So if we're trying to solve this diagram and we want to solve for little a, we're going to use this piece of the sine rule. Let's try one more. Okay. In this diagram PQR, they want us to find R. So if they want us to find angle R, we must be given the half pair across it. We must be given side R. And the other pair that is given here is P and little p. So we need to find, this is the angle we need to find. We need to find angle. So because we're looking for angles, it means we're going to use this version of the sine rule where the angles are in the numerator. Again, we're going to use this version, but we're going to start off with what's unknown. Because R is unknown, we're going to start off with that piece. So that's our unknown, and we know we have that piece here. And the other pair we're given is the P and the side P. So which formula will we start off with? We're going to start off with that one, and specifically, we're going to be starting off with sine R over R, and this is our half pair we're given, and that's our half pair we're given. And on this side is sine P over P, and that's our full pair we're given. Okay, I think that was a lot to take in. Let's take a short break and come back to see how we can apply the sine rule. Hi, welcome back. So before the break, we were talking about the sine rule. Now we're going to see how we can use the sine rule to find the length of a side in a triangle. Let's go to an example. Here we're given triangle ABC, and they've given us the question that says, find the value of C. So we need to ask ourselves, what are we given? Looking at the diagram, we can see we're given this angle, 35 degrees, this angle C, 105 degrees, and the length of this side AC, which is 14 units. So we're given two angles and one side. The next question we're going to ask, what are we finding? So they want us to find the value of C. This is what we need to find. We need to find a side. So we need to find the side labeled little c, or we can call it AB, the length of AB. The next question we need to ask, remember for sine rule, we need to have one pair and one half pair. So we need to check, do we have one pair and one half pair? Let's go back to our diagram, and if you look clearly, here's our full pair. We've got one angle and one side, and we have a half pair containing our unknown side. So we have this side and the angle across it. So yes, we do have one pair and one half pair. Which version of the sine rule are we going to use? Remember, there were two versions of the sine rule. Because we're looking for a side, we've got to use the version of the sine rule that has the sides on top, meaning that version, which is A over sine A, B over sine B, C over sine C. And specifically, which part of it are we going to use? Because the half pair we have is the C pair, we're going to use that piece, and the full pair we're given, which is this piece here, is the pair with the B's. We're going to be using these two parts of the equation to help us start. So again, we're going to be using C is what we need to find over sine C. That's our half pair. And B over sine B, that's our full pair. Now we're going to use the values in our diagram to substitute into this equation. So angle C is 105, it goes in there. Side B has a length of 14 units, and we put that one in there. And finally, sine B and the angle B is 35, and we substitute that in. Then we'll go to our calculator. Sorry, before we get to our calculator, we first multiply throughout by sine 105. So we end up with this fraction. And all we do now is put this into our calculator. Okay, so we're going to put this right-hand side into our calculator. 14 times sine of 105 divided by sine of 35. And our answer is 23,57. But we want to round off our answer. So if we're rounding off, we're going to end up with 23,58. And so our value for C is 23,58. Now, there's something that we have to remember when we're dealing with triangles. When we're dealing with triangles, we have to do a kind of a checksum just to make sure that our answers make sense in the context of the problem. So let's go back to this answer that we've just got now. If you look at our diagram, 35 is less than 105. So the side across this, we expect to have a smaller value than the side across this. In other words, we expect C to be bigger in value than 14. And if you look at our answer, C is quite a bit bigger than 14. It's almost 24 units. So that's how we check to see if our answers make sense in the context of a diagram. You don't need to do this, but it's a useful tool to check. Okay, so we found one length of one of the sides. Now we're going to use the same diagram and we're going to find the other missing side. So let's go back to our diagram again. Okay, so now they want us to find the value of A. So again, it's the same diagram, so nothing's changed except what they're asking us to find. Now instead of C, we need to find A. So what are we given? Again, we've still been given two angles in one side. So we've still been given these two angles and this side. What are we finding? We're finding another side. We're finding little a, or in other words, another way we can call this line, we can call it BC. So we're finding the length of BC. Okay, to use the sine rule again, we need to check. Do we have one full pair and a half pair? Now, go back to the diagram and you'll realize our full pair is still this pair here. But we have a small problem here. Our half pair, we want to find this little a. We don't have the angle A just yet. So our first problem is to find angle A. If we did find angle A, it means we would have the half pair A and little a. Okay, so how can we find angle A? We're going to find angle A first. We'll use three angles of a triangle. Okay, but before we do that, let's just think about which version of the sine rule we're going to use again. Again, what are we finding? We're finding a side. And because we're finding a side, we're going to use the version of the sine rule that requires this, that has the sides on top. So we're going to be using this version. And because we're going to find, we're looking for little a, we're probably going to use that piece. And the full pair we're given is B and sine B. So that's the two that we are going to use. So again, let's just make sure we understand this. Because we're given the half, we've got to first find this angle A here. And when we do, we can use this half pair here. And we can use this full pair and use this equation to find our sine rule, to use our sine rule to find little a. Okay, so there's a neater version of what we're doing. We're going to say A over sine A equals to B over sine B. We're simply going to substitute first to find our A using three angles of a triangle. And because we have 105 and 35, we subtract that from 180 degrees, and we find that our angle A now has a value of 40 degrees. So we're going to use that 40 degrees in our sine equation here. Substituting, we're going to get sine over sine A, and there's the 40 we just found now, equals to B, which is 14, all over sine of 35. We're now going to multiply both sides by sine of 40, so we have a nice, neat little fraction that we can enter into our calculator here. And again, we're going to enter this into the calculator exactly as I showed you earlier. And let's see if we can do that in the calculator quickly. Okay, so now we're going to be putting this into the calculator. Let's clear that up first. So it's 14 times sine 40 divided by sine of 35. And again, remember, we're rounding off to two decimal places. So whatever the answer we get here, which is 15,6893, we're going to have to round that off. Okay, so our rounded answer, 15,69 units. Now, again, remember, we need to check if this answer makes sense in the context of our problem. In other words, check this against the angle, just as I showed you earlier. So let's go back to the board again and see if it makes sense. So this angle, 40, is slightly bigger than 14. So we expect our answer, this angle 40 is slightly bigger than 35. So we expect our answer for A to be slightly bigger than 14. And if you look clearly at our answer, we've got 15,69 units, which is greater than 14. So in the context of that, we can see that our equation does look correct. Our answers do look like they make sense. And we should be on the right path. So we're finding the value of A. And we've just decided that we're going to use this version of the sine rule. We need to find A. We're going to use angle A, which we have to find first, and we're going to use B over sine B. Both of these we have. We don't have angle A yet, but we can find it. If we go back to our diagram and remind ourselves how we're going to find angle A, we have these two angles, and A is the third angle in this triangle here. So all we need to do is subtract those two angles from 180 degrees. So A will be 180 minus 105 plus 35, the sum of the other two angles. A is then equal to 40 degrees. So back to our diagram. A is now 40 degrees. Again, let's check our full pay and our half pay. Our full pay is that one. And now we have our half pay containing our unknown as well as the angle across it. So A over sine A, we have now that little piece from our puzzle, and now we're going to substitute this in. So we're going to substitute the A for 40 degrees, the angle A. B was 14 degrees, and sine of B will be sine of 35 degrees. Now, we've just got to do some algebra to complete this. We multiply both sides by sine of 40, and we end up with a neat little fraction that we've got to put into our calculator because we multiplied both sides by sine of 40. So 14 times sine of 40 divided by sine of 35. Again, let's go to our calculator and put this in. Okay, so we're going to put this fraction into our calculator. 14 times sine 40, and we need to divide that by sine of 35 equals, the answer we get on our calculator is 15,68932. And remember again, for this session, we are rounding off to only 2 decimal places. So because we've got a 689, it will become 15,69. So A is equal to 15,69 units. Now remember, I reminded you earlier, it's very important, or it's quite useful to do a checksum to make sure that the answer you found makes sense in the context of the problem. In other words, does it fit the triangle? So let's go back to our triangle and see if our answer makes sense. Now, if we look at what we found earlier, we notice that 35, the angle 35 was across 14. And the side we found now was across angle with this angle A with the size of 40. So the angle A, sorry, let me just get my pen quickly. Angle A had a value of 40 degrees. And 40 degrees is greater than 35 degrees. And the side across 35 degrees was 14 units. So we need to check that the answer we found now is greater than 45. And if you look at our answer from here, 15,69 is greater than 15,69 is greater than 14, which means our answers do make sense. So this little tool where we do this checksum is not necessary, but it does help us to check our answers to make sure they fit within the context of the problem. It's a good way to make sure that we haven't made an error in any of our calculations. Okay, we are going to stop right here and go for a quick ad break. We'll see you at the end of that. Hi, welcome back. So earlier, we used sine rule to find the length of a side of a triangle. Now, we're going to use sine rule to find unknown angles in non-right angle triangles. Let's look at an example. Here we're given triangle PQR, and they want us to find the value of angle R. So our unknown is an angle this time instead of a side. So just as before, when we analyze the question, we got to look at what we have and ask some questions. So let's begin with our questions. First question, what are we given? Let's look at our diagram again. What are we given? We're given one side, two sides, and we're given an angle. So in this case, we're given two sides and an angle. The next question, what are we finding? What do they ask us to find? They wanted us to find this angle here, angle R. That was the question. They wanted us to find angle R. So we got to find an angle. Do we have, again to use the sine rule, we need to have one pair and one half pair. So let's go look and see if we have a full pair. And our full pair we have is the P's. So we've got angle P and we've got the side across it. So this is our full pair. Okay. And what is the half pair we have? Let's check. Do we have the half pair? We're looking for angle R. Do we have the side across R? Yes, we do. So we've ticked both those boxes. We've got our full pair and we've got our half pair. Next question, which version of the sine rule are we using? Again, what are we finding? We're finding angle R. Because we're finding angle R, we're going to use the version of the sine rule that has the sine R in the numerator because it just makes our calculation easier. So we're going to be using a piece of this version of the sine rule. Okay. So we've got the angles on top because we're looking for an angle, and we've got to decide which one we're going to use. So what are we going to use? Because we have the full pair of P, it means that's the full pair we're going to use, and because we're looking for R, we're going to use that half pair. So we're going to use these two pieces of our equation. So this is the version of the sine rule we're going to use. Sine R over R equals to sine P over P. Now, substitute all the relevant values in. Substitute 4 for R. And let's substitute angle P 75 and side P 9 units. Rearrange this to make sine R the subject of the formula. Multiply throughout by 4 and we end up with this neat fraction, which we will then put into our calculator. Now, we have to remember something. At the moment, we're looking for an angle. And what's different about looking for an angle versus looking for a side? We need to use the second function or the shift key on our calculator. So, because we're finding angle R, we're now going to use the second function sine on our calculator with this fraction in. Let's go to our calculator and see what we have to put in. Okay, so we're going to say shift sine, and now numerator we've got 4 times sine 75. In the denominator we have a 9. Oh, sorry. Okay, and we have an answer of 25,423, and we've got to round it off to 2 decimals, so we're rounding it off to 25,42 degrees, and that's the value of our R, 25,42 degrees. Okay, so we've now found out how you find an angle using the sine rule. We're now going to solve a triangle. What does it mean to solve a triangle? To solve a triangle means we need to find all the missing lengths and all the missing sides and all the unknown angles. So let's look at an example where we can do that. So here's triangle KLM, and they want us to solve the triangle. They want us to find all the missing angles and sides. So we have to ask our questions again like we did earlier. First question, what are we given? We're given, again, 2 sides and an angle. Okay. What can be found using the given information? So using the given information, we've got 1 full pair here, and we have 1 half pair here. So it means we can use the sine rule. In other words, we can find angle theta or angle M. That's what we can find first. So using the sine rule, that's what we can find first. Right. Which version of the sine rule? Again, because we're finding an angle, we're going to start off with the version of the sine rule that has the angles on top. Because our triangle is KLM, sine K over K, sine L over L, sine M over M. And specifically, again, we're going to be using just the pairs that we have, which we'll do in a second. Okay, once we found theta, what is the next thing we can find? We will solve it slowly, but just to make sure where we're heading. Once we found this angle theta, we'll have 2 angles in our triangle. So once we have theta, it will be quite easy to find angle K using 3 angles of a triangle, the sum of angles of a triangle. And finally, the last thing we can solve once we have K, we can find the side across from K, and the side across from K is LM, and that's the last thing we'll do in our solving of this triangle. So let's start at the first step, and the first step we're going to do is find theta. Let's get to a clean slide. Okay, so here's a neater diagram, and we're going to find sine theta over 10, that piece, equal to sine of L, 108, over 20. So there's our equation we set up. Now we've got to just make sine theta the subject of our formula by multiplying throughout by 10. Put that into our calculator like we did earlier. This should be quite simple now. And so we get an answer of theta being shift sine, and we put this into our calculator. And when we put this into our calculator, substitute all of these into our calculator, we'll get an answer of theta equals to 28,39. So this angle is 28,39. Now, we need to find angle K using 3 angles of a triangle. So we've got 108, we've got 28,39. So K is easy to find now. You just subtract those from 180, and K is now 43,61. So 43,61 degrees. Okay. Here's a neater diagram again with all the information that we found already. We found that M is 28,39. We found K is 43,61. What's left to find is little k. We need to find this piece here. So again, we're going to use that full pair, and we're going to use that half pair to make up our equation, to set up our equation that we can solve. So again, our full pair and our half pair, we're going to start off with what's unknown. Because we want to find k, we're going to say k over sine of 43,61 will equal to this pair here. So it will be 20 over sine of 108, and that's the equation we've set up. We make k the subject of the formula again by multiplying throughout by sine of 43,61. And our calculator will give us the answer, and we round it off to 2 units, to 2 decimal places. So k will equal to 14,5. Okay, so we found out that k was 14,5 units. So again, let's do our quick check to see if our answers make sense in the context of our problem. Our greatest angle is 108 degrees, and the side across it is 20. Okay. The next biggest angle is 43,61, and the side across it is 14,5. So that looks correct. And the third angle and side that we found is 28,39, and the side across it is 10. So we've checked our answers. It looks like the biggest side is across from the largest angle, and the smallest side is across the smallest angle. So our checksum is also complete. Okay, we're going for a short break. We'll be back after this. Hi, welcome back. Remember when we started the session, we asked the question about how a pilot would know in which direction to fly his aeroplane? Let's get back to that question. So, here's a problem faced by our pilot. He wants to fly due east. In other words, he wants to fly to B, to the destination at B. But there's a strong wind that's blowing at 100 kilometers per hour in a southeast direction, that way. If the plane has a cruising speed of 450 kilometers per hour, in what direction should the pilot fly to reach his destination? So direction means we're talking about angle. We're talking about theta. So what they're asking us is, what direction must the plane fly in order to reach his destination at B, taking into account the wind force coming in that direction at him? Okay, so let's look at this diagram a little bit closely. Right, what are we given in this diagram? So, we're given this angle 45, so we're given one angle, and we're given this side 450 kilometers per hour, and we're given this side 100 kilometers per hour. So we've got two sides and an angle. Can we use the sine rule? Do we have one pair and one half pair? There's our full pair. Okay, we want to find theta, and we have the side across it. So yes, we can use the sine rule. Right, so let's write our equation, set up our equation using the sine rule. And again, which version of the sine rule are we going to use? Because we want to find theta, we're going to start off with the version that has sine theta in the numerator. So sine theta across over the side across from theta, so it will be 100. We'll substitute this 100 in, and we will use our other full pair, and our other full pair will be sine of 45, this angle here, over 450. Now, we've got to just do some algebra to get our sine theta on one side, and we multiply throughout by 100. And then, because we're finding theta, we're going to use the shift function on our calculator, and we're going to find the value of theta and round off our answer to 2 decimal places. So we end up with an answer of 9,4 degrees. So what does this mean in the context of our problem. It means that this angle is 9,04 degrees. So, in which direction must the plane fly? In other words, the plane needs to fly at an angle of 9,04 degrees north of east. So basically, that way, at an angle of 9,04. Okay, if we did try and do a checksum again to see if our answers look correct, 100 is across from 9,04 and 45 is across from 450. So obviously, we did expect our answer to be significantly less than 45, which was the angle across 450 degrees. So in the context of that, our answer does look correct. Okay, now we've completed with all the formalities of the sine rule. Let's do a quick summary to recap what we've done thus far. What is the sine rule? So the sine rule using triangle ABC is a rule that states that sine A over A is equal to sine B over B, which is equal to sine C over C. And remember, there is a second version to this. This version we use when we are trying to find our angles, because our angles are in the numerator. Okay? And the second version of the sine rule we've used is this version, the reciprocal version, where all the sides are in the numerator. Okay? And we use these whenever we're trying to find the length of one of the sides of a triangle. It just makes our calculation easier, and this version reads A over sine A equals to B over sine B equals to C over sine C. Right. Again, let's revise when we use the sine rule. So we've made a bit of a rule that we said you're going to use the sine rule when you're given one full pair of angles and sides and one half pair. So another way of stating that is we either use the sine rule when we're given two angles and a side, okay, or when we're given two sides and an angle. What's important about this is that angle is not the including angle. Okay, so basically when we're using the sine rule, you can use any full pair and any half pair. So if I wanted to find C, I need to be given angle C and any other pair along with it. Okay, so we've almost reached the end of our lesson for today, where we dealt with the sine rule. Let's do a quick recap on what the sine rule is and how it's used. So the sine rule for any triangle ABC is sine A over A equals to sine B over B, which equals to sine C over C. This version of the sine rule we use predominantly when we're trying to find angles. So if we want to find an angle, then we will use this version because the angles are in the numerator. The second version of the sine rule we have is little a over sine A equals to B over sine B, which equals to C over sine C. This version of the sine rule has all the sides in the numerators, and we use this version when we're trying to find the sides of an angle. And when we're deciding which pair of these equations we're going to use, it will be determined by what has been given. So let's look at an example again. When do we use the sine rule? We use the sine rule when we're given one full pair. So in other words, when we're given a set of angles and the matching side across it. Okay, and when we have one half pair. So in other words, we can use the sine rule either when we have angle, angle, side, or when we have side, side, and angle. But remember, we don't use sine rule if we have the including angle. So sine rule is used when we have side, side, angle, when not the including angle is given. So for example, again, just to recap, if we given that as our full pair, we given b and little b, and we want to find, for example, little c, then we have to be given the rest of this half pair. In other words, we need to be given angle c. So sine rule kind of works, if you notice, in a bit of an x fashion. So we need one full pair, and we need one half pair. Okay, that brings us to the end of our session, and so far we've covered the sine rule today. We've done that. In our next session, we'll be doing a little bit more on the sine rule and touching on a bit of, we'll be introducing the area rule as well. Okay, so I hope you'll join us next time. Thanks. Bye.